Hello, I'm Alex Liskey, and welcome to my ME 532 final project, where we are tasked with creating a pick-and-place application in a simulation environment of our choice. I chose Matlab here, and you run my project by opening up main.mlx and adding the appropriate folders to the path. Here's all the scripts that I use. They're open here. I'll talk about them later. But the important stuff is that I've created this simulation example such that you can create as many boxes as you wish by filling out rows of this box positions variable. And it will initialize a box in each of these locations and then place each of those boxes in the drop positions that you specify here in the corresponding element of the drop positions variable. So that allows you to generate as many boxes as you wish and place them anywhere you wish and create some cool stuff. So let's just run it and see how she works. Now I'll include some commentary here or there while she's running. You see I've initialized my 3 boxes in the box positions variable where we've got. So this is something kind of interesting. You see how it's stopping just before, kind of above the box that it's trying to pick up, this one right here. That's because I noticed that on its approach, the collision wasn't working great between the teeth of my end effector and the box that it was trying to pick up. The trajectory that the solver would choose to approach at sometimes caused the teeth to clip through the box. So I effectively added an extra waypoint to have the robot stop about pi over, well, this is not going to sound right, but I had this arm be pi over 8 offset to where it was supposed to be. That way it could approach just above the box and then lower that one joint down as necessary to reduce, or in some cases eliminate, the clipping through the sides of the box. Hopefully we can see that in action. Yeah, so it's arriving at the waypoint just above, and we're going to see this joint drop to the final box grabbing location. Box grabbing pose, maybe I should say. When this little rod comes out of the box, that signifies that it's been acquired by the end effector. Yeah, the solver is having trouble avoiding the wall here, but it looks like it just barely made it. And there she goes. Now that we've stacked all of our boxes according to the drop positions array here, you can see that we've got, 278, 278 plus 0.1, 278 plus 0.2. Now that all of them are stacked, I just have it programmed to return to its home position. All right, there's the first demo. I've chosen another set of initial box locations that highlights some other functionality that I've added. So I'm just going to comment some of this out, and we can run the other simulation. Yeah, so now I've got new box positions and new drop positions. Saving that. We can run it. Now we've got the 3 boxes aligned very close to these cylindrical obstacles that I've added. Maybe you can see that slow drop into position to acquire the box more easily here, because it also helps avoid collision with the cylinder as it's leaving and picking up. Yeah, so there we go. Yeah. Without this step, it would have just clipped through the entire box. Now we're only clipping through a little bit of the box. So here's another cool piece of functionality that I programmed in. By default, the inverse kinematic solver will choose the pose that's kind of, I guess, closest to the seed pose that I provided. I'll talk about all this in the report and in the the tech tour video where I go over how everything works. But you notice how the end effector here is parallel with the y-axis, and it was parallel with the x-axis to fit between the cylinders earlier. I added some extra logic to check for collisions for a bunch of inverse kinematic solutions and rerun the numerical solution in the case of world collision or self collision with the robot. So this is an example of something extra that I can do now that I've added that in. Because I'll talk about this in the report, but the robot tried to pick up the box with its end effector parallel to the y-axis down here, and it gave me a world collision error because it would run into the cylinders. But now that we have that check, it can squeeze itself through the cylinders at the appropriate angle and successfully pick up the box. I'm not stacking them this time, I'm just aligning them in a row. The boxes, that is. It is taking a while. The last thing I'll note is that you can see that there's the trajectory dots here. I'm not actually doing any velocity control or any velocity constraints or angular velocity constraints on any of my joints, and I'm not plotting a consistent time step here. I'm just plotting the interpolation points between the key poses that the solver is providing me. So that's why you see like these spread apart points like this next to these really tight points over here. But Yeah. Last illustration of that uh, that joint, or yeah, that joint to uh, revolve to come in from the top to avoid some pretty heinous clipping. And we've got the end effector in the right position to just squeeze through those cylinders. As you can see, this blue wall here is a persistent obstacle that the robot has to avoid to put the boxes in the appropriate space. And there we go. I think Matlab is just, yeah, Matlab is also just a little bit slow, but it provided me with a lot of the framework that was nice to be able to program some of these, um, yeah, some of these advanced features like the rotation of the end effector there. But we're going to wait for her to return to the home position and then conclude this part of my video presentation. All right, I think she's landed back in the home position. Yeah, thank you very much for watching. And if you do play with my project, I'm sure there are ways to arrange boxes in interesting patterns that you can, yeah, that you can have fun with. Yeah, thank you very much. Have a great day.